Did you know that at just 7 years old, Carl Friedrich Gauss, a mathematical genius, astounded his teachers by instantly summing the integers from 1 to 100? Yes, you heard it right. This little prodigy from Brunswick, born on the 30th of April 1777, was destined to leave an indelible mark in the world of mathematics and beyond. In his early years, Gauss attended elementary school where his extraordinary potential was noticed almost immediately. His teacher Buttner and his assistant Martin Bartels were left in awe when Gauss effortlessly calculated the sum of integers from 1 to 100. The young Gauss was able to discern that the sum was just 50 pairs of numbers, with each pair summing to 101. A remarkable feat for a 7-year-old, wouldn't you agree? In 1788, Gauss began his education at the gymnasium, thanks to the support of Buttner and Bartels. Here, he engaged in the study of High German and Latin. But his intellectual journey didn't stop there. With a stipend from the Duke of Brunswick-Wolfenbüttel, Gauss entered Brunswick Collegium Carolinum in 1792. This was where his mathematical prowess truly began to shine. Gauss independently discovered Bode's law, the binomial theorem, and the arithmetic geometric mean, along with the law of quadratic reciprocity and the prime number theorem. His mind was a mathematical marvel, churning out groundbreaking discoveries one after the other. By the time Gauss left Brunswick to study at Göttingen University in 1795, he had already made significant mathematical discoveries. His journey was only beginning, and the world of mathematics was about to be revolutionized by this prodigy from Brunswick. His story is a testament to the power of a curious and brilliant mind, forever reminding us of the boundless potential of human intellect. Even without a diploma from Göttingen University, Gauss had already made one of his most significant contributions to mathematics. As a young man, he left Brunswick to study at Göttingen University under the guidance of Professor Kastner. Despite often poking fun at his mentor, Gauss's time at the university was far from unproductive. His intellectual curiosity found companionship in fellow student Farkas Bolyai. Their friendship, which blossomed in 1799, was marked by a vigorous exchange of ideas that would continue for many years. Such was the intensity of their intellectual camaraderie that they left a trail of letters filled with mathematical musings and theories. But it was not just the friendships that Gauss forged during his university days that left an indelible mark on his life. His early departure from Göttingen in 1798 came with a groundbreaking discovery. He found a way to construct a regular 17-sided polygon, or 17-gon, using nothing more than a ruler and a pair of compasses. To truly grasp the magnitude of this discovery, we must travel back in time to the era of Greek mathematics. The ancient Greeks had already shown how to construct regular polygons with 3, 4, or 5 sides, but when it came to polygons with more sides, they were stumped. This problem, which had confounded mathematicians for centuries, was finally solved by our young genius from Brunswick. This achievement was far from trivial. The construction of a regular 17-gon was a major breakthrough in the field of geometry. It was a testament to Gauss's mathematical prowess and his ability to see patterns where others saw chaos. It was proof, if any was needed, that Gauss was destined to leave his mark on the world of mathematics. His discovery was later published as Section 7 of his famous work, Disquisitiones Arithmeticae, where it took its rightful place among the many other mathematical gems unearthed by Gauss. This discovery, a major advance since the time of Greek mathematics, was a testament to Gauss's genius. His university years may have been unconventional, but they were instrumental in shaping the mathematical titan that Gauss would become. After returning to Brunswick, Gauss, armed with a stipend, devoted himself to research and produced his famous work, Disquisitiones Arithmeticae. Carl Friedrich Gauss, the prodigy from Brunswick, embarked on a new chapter of his life after his studies at Göttingen University. His return to Brunswick marked the beginning of an era of prolific mathematical research, fueled by a stipend granted by the Duke of Brunswick. The Duke's support allowed Gauss to immerse himself in his work, unburdened by the need to secure employment. As part of his agreement with the Duke, Gauss was required to submit a doctoral dissertation to the University of Helmstedt. His dissertation was a discussion of the fundamental theorem of algebra, a cornerstone of algebraic understanding. With this work, Gauss demonstrated his profound insight and analytical abilities. His advisor Pfaff, whom he knew prior to his doctoral studies, was undoubtedly impressed by the young mathematician's brilliance. However, the crowning achievement of this period in Gauss's life was undoubtedly the publication of his book Disquisitiones Arithmeticae in the summer of 1801. This work was an in-depth exploration of number theory, a field that Gauss had shown an affinity for since his early days in Brunswick. The book was divided into 7 sections, each delving into different aspects of number theory. The last section, however, was a departure from the previous ones. It discussed Gauss's groundbreaking construction of a regular 17-sided polygon, or a 17-gon, using only a ruler and compasses. Disquisitiones Arithmeticae was met with widespread acclaim and solidified Gauss's position as a leading figure in the world of mathematics. His innovative approach to number theory and his detailed analysis of complex mathematical concepts showcased his exceptional talent and profound understanding of the subject. The publication of Disquisitiones Arithmeticae was a pivotal moment in Gauss's career. The work not only established him as an authority in the field of mathematics, but also laid the foundation for future mathematical research. This work, with its 7 sections primarily devoted to number theory, established Gauss as a leading figure in the field of mathematics. Not just a mathematician, Gauss also made significant contributions to astronomy with his prediction of the orbital positions of Ceres. Let's take a step back to the early 19th century. It's June 1801, and a new small planet has been discovered. This celestial body named Ceres was found by Italian astronomer G. Piazzi on the very first day of the new year. However, Piazzi could only observe 9 degrees of its orbit before it vanished behind the sun's blinding glare. Enter Zach, an astronomer who had become acquainted with Gauss a few years prior. He published several predictions of Ceres's position, including one by Gauss, which stood out from the rest. It differed greatly, but would it prove to be accurate? Fast forward to December of that same year. Ceres was rediscovered, and lo and behold, it was almost exactly where Gauss had predicted. Now, Gauss didn't reveal his methods at the time, but we now know he used his least squares approximation method. This mathematical technique, which minimizes the sum of the square differences between the observed and predicted values, was innovative for its time. This prediction was more than just a successful guess. It was a display of the practical application of Gauss's mathematical theories. In essence, Gauss used his mathematical prowess to solve a real-world problem, a feat that was nothing short of revolutionary. But why does this matter? Well, Gauss's prediction of the orbit of Ceres demonstrated the power of mathematics in understanding and predicting natural phenomena. His work bridged the gap between abstract numbers and the tangible world, showing us that mathematics is not just about numbers and equations, but also about understanding the universe around us. So when we look up at the night sky and marvel at the celestial bodies, remember that it's not just telescopes and eyes that can unravel their secrets, but also the power of mathematics. Gauss showed us that, and his work continues to influence the field of astronomy to this day. With this, Gauss had not only made a significant contribution to astronomy, but also demonstrated the practical applications of his mathematical theories. From his humble beginnings in Brunswick to his significant contributions to mathematics and astronomy, Carl Friedrich Gauss left a lasting legacy. Born in the late 18th century, Gauss started his journey in elementary school, where his potential was noticed almost immediately. His genius was such that he could sum the integers from 1 to 100 instantly, a feat that left his teachers astounded. Gauss's academic journey took him to Brunswick Collegium Carolinum and later to Göttingen University. His time at these institutions was marked with an array of discoveries. He independently discovered Bode's law, the binomial theorem, the arithmetic geometric mean, the law of quadratic reciprocity, and the prime number theorem. He also made a significant breakthrough in the field of geometry with the construction of a regular 17-sided polygon using just a ruler and compasses. Gauss's contributions extended beyond mathematics to the realm of astronomy. His prediction of the orbital positions of Ceres, a small planet, was notably accurate and highlighted his mastery of the least squares approximation method. His work in astronomy was so influential that he was proposed to be the director of a new observatory in Göttingen. His life's work spanned various fields such as number theory, analysis, differential geometry, geodesy, magnetism, and optics. His profound influence on these disciplines is evident in his seminal work, Disquisitiones Arithmeticae, which is devoted to number theory. Gauss's legacy is not confined to his own era. His theories and discoveries continue to impact the world of mathematics and science today. They form the foundation for many current studies and have paved the way for future innovations. His life, marked by intellectual curiosity and rigorous investigation, serves as an inspiration for generations of scholars. Carl Friedrich Gauss, a prodigy, a pioneer, and a genius, has left a lasting legacy that continues to shape the world of mathematics and science to this day.